Morning, dear friends. Let us try to complete one more topic later where we get one damn sure question for EPSET, and for NEET it is a 4 marks weightage bit. That is about your wave optics. Okay. So first ID, if I'm talking about nature of light, so many theories have been given for explaining the nature of light better. The first in that one was right now if I'm writing particle nature of your light, which has been given by your how much? Newton. Then afterwards it has been performed by your Einstein's photoelectric equation. First one is about your particle nature. Particle nature of a light was being given by your Newton. The next one is wave nature. Wave nature of light was being given by your Huygens. Okay. In Huygens principle, we will be studying about your Young's double slit experiment. Young's double slit experiment. It proves the wave nature of your light beta. Okay, this is an experimental proof for the wave nature of your light. It is experimental proof for wave nature of light. Okay, wave nature of light experiment द्वारा prove చేశారు. What is your answer beta? YDSE Young's double slit experiment. Okay na? Then third one was dual nature of light. Dual nature of light. When world was fighting whether to decide the light is a wave or particle, then our new scientist has been come into existence. His name was none other than Einstein. So it was your Einstein sir who has given me the wave nature of a light, and he told that it is having both particle nature and wave nature. Depending upon the situation, it will be acting as a wave or it may be a particle. Am I clear? So in the wave optics chapter, we'll be studying about these phenomena very importantly, very small chapter. One, we'll study about your Young's double slit experiment. Okay. Number two, we'll be studying about your diffraction. And number three, we'll be studying about your polarization. Okay. Polarization beta, it says that transverse nature of light. Transverse nature of light is being given by your polarization. Whereas the first Young's double slit and diffraction experiments gives me the wave nature of your light. Wave nature of light has been experimentally proved by Young's double slit experiment and diffraction. Young's double slit experiment, YDSE and diffraction. The next one is polarization gives me the transverse nature of your light. Clear? Sure. What you are talking about? We are starting about a new topic that is of your wave optics. Wave optics is having 4 marks for your NEET. Okay, and 1 mark for your EPSET. Okay, and again 4 marks for JEE Mains. Okay, so nature of light. First, we're talking about your particle nature. Particle nature of light was being given by Newton. It was being given by your home Newton. Next one is wave nature of light. Wave nature of light was being given by your Huygens theory. In Huygens theory, we'll be studying about your YDSC, which is an experimental proof for the wave nature of a light. Then came our very famous scientist, that is about your Einstein sir. Einstein has been given me the both particle nature and wave nature of the light, that we call it as a dual nature of a light. Now in this chapter, what we are going to study is, in this chapter, we are trying to revise the formulae of your YDSC, diffraction, polarization, and some of the problems related to this topic. Am I clear? Chalo. First heading line है ना, Huygens principle. Huygens principle. What does Huygens principle says that, beta? It gives the concept of your wavefront. Gives me the concept of what? Wavefront. What is the wavefront, beta? So it is a focus, or it is a locus of the points which are in the same state of your vibration, isn't it? Like say for example, the ray of light is going like this. Parallel ray of light is going like this. If I take the locus of one point in this one, like say one particle here, one particle here, one particle here, and one particle here, and attach all of them, this is making an angle of 90 degrees with the ray of light. This dark ray, black color is nothing but ray of light. This blue color light is nothing but equal to your wavefront. So the locus of this star mark point, these dots are right now for me locus. The locus of all the points which are in the same state of vibration is called as of your wavefront. We famously call this one as of your plane wavefront. Plane wavefront. Clear? Okay. If the ray of light is falling on the, like say for example, convex lens on the right. This is your principal axis. When a ray of light is being incident on a principal axis like this is a ray of light. What it will be trying to do, beta? It will converge all the rays at one point. So this is acting as a what? Converging lens. This is your convex lens. Now tell me what type of wavelength is being incident on this one. Take all the dots which are in the same state of vibration. That means when a plane wavefront is incident on a convex lens, what type of wavefront we are getting, you see right now here, beta. So if I take all the points which are in the same state of your vibration, we are trying to get right now for me here converging spherical wavefront which are in the same state of your vibration, isn't it? Now see what you got an idea. When a plane wavefront is been incident, when a plane wavefront is incident on a convex lens, we'll be getting converging spherical wavefront. Spherical wavefront. That means point source of light will always be giving me what, better? Like say this is the point source of light. Light is going in all the directions like this. Like if I take a candle and keep it in a room, the complete room will be getting the lighting because light travels in all the directions like this. Isn't it? Now if I take the locus of all points which are in same state of your vibration. So if I attach all of them, we are getting what type of wavefront, beta? The spherical wavefront. And it is going outward like this. Okay, so can I say that a point source of light, point source of your light gives what type of wavefront, beta? Spherical wavefront. Spherical wavefront. Am I clear? Am I clear? Done? What's here? Huygens principle can explain the concept of your refraction. It can explain the concept of your reflection. It can explain the concept of your diffraction. Okay, Huygens gives me the refraction, reflection, and diffraction, but it cannot explain. It cannot explain polarization because it is a transverse nature of light. Am I clear? If someone asks you which phenomenon is not explained by Huygens, reflection, refraction, diffraction, and polarization, what is your answer? Obviously, polarization. What is beta? So I hope everyone got about what do you mean by the Huygens wave principle. Okay. So next one is we'll study about your interference and diffraction. What do you mean by interference? What do you mean by interference, beta? The superposition of the waves. When two waves at the same position, two waves at the same position at same time meet. That point is called as of your point of interference. Okay. Like say for example, if I'm talking about the first wave, in this one, when two waves are meeting at one single point beta like this. So this is a wave one having amplitude A1, amplitude A2. Intensity of this one is I1, intensity of this one is I2. At the point they will be meeting. So the point of meeting may be a destructive interference or constructive interference. అంటే అది బ్రైట్ పాయింట్ కావచ్చు డార్క్ పాయింట్ కావచ్చు అవునా కదా అంటే ఏంటి ఒక రూమ్ లో నీకు 4 ట్యూబ్ లైట్స్ ఉన్నాయి అనుకోండి అన్ని 4 ట్యూబ్ లైట్స్ కనుక ఆన్ అయితే వాట్ ఈస్ హ్యాపెనింగ్ బ్రైట్నెస్ విల్ బి ఇంక్రీజింగ్ ఓన్లీ 2 ట్యూబ్ లైట్స్ పెట్టాను అనుకోండి లేకపోతే ఒకటి ట్యూబ్ లైట్ ఆన్ అయింది అనుకోండి రూమ్ ఏమైపోయింది డల్ కనిపిస్తుందా లేదు సో ద ఇంటెన్సిటీ విల్ డిపెండ్ అపాన్ వాట్ నెంబర్ ఆఫ్ సోర్సెస్ ఓకే ఈ టూ వేవ్స్ ఎప్పుడైతే ఇంటర్సెక్ట్ అవుతున్నాయో at the point of intersection we get a resultant amplitude a resultant is equals to under root of your this formula you need to remember a1 square plus a2 square plus 2a1 a2 into your cos of your phi. Phi is the angle between a1 and a2. అదేవిధంగా resultant intensity I resultant is equals to the formula is I1 plus I2 plus this is a 2 root I1 root of your I2 into your cos of your phi. So these are the two formulas you need to remember in the interference. A resultant is equals to root of your A1 A2 whole square plus 2A1 A2 into cos phi and resultant amplitude is this one. And intensity is being given by the formula. Intensity is given by the formula. I is equals to your I1 plus I2 plus 2 root I1 I2 into your cos of your phi. So I can say that intensity is directly proportional to square of amplitude. రాశి నన్ను ఎక్కడ వరకు Clear, beta? So whenever two waves are meeting at some position at the same time, same position and same time, the amplitude of the resultant amplitude is given by the formula under root of a1 square plus a2 square plus 2a1 a2 into cos phi, and resultant intensity is given by the formula a1 i1 plus i2 plus 2 root i1 i2 into your cos phi. Okay. The next one is very important formula, beta. The relation between phase difference and path difference. Path difference are represented by delta x, and phase difference is represented by delta phi. గుర్తుందా ఎవరికన్నా? ఐపీఎల్ కూడా చదివింటారు వేవ్ ఆప్టిక్స్ అయ్యేటప్పుడు. What is that? Delta phi is equals to very important formula beta 2 pi by lambda into your delta x. ఇది నేను SHM లో కూడా రాపించాను. Phase difference delta phi is equals to 2 pi by lambda into delta x. Delta x అంటే path difference నాను, అండ్ delta phi అంటే phase difference. ఓకే చూడండి, ఒకవేళ ఇంటెన్సిటీ మాక్సిమం అయింది అనుకోండి, ఫర్ maxima path difference will be delta x is equals to n lambda, and delta phi will be equal to your 2n into your pi, where n value will be 0, 1, 2, 3, go on like that. Okay. Now for minimum intensity, path difference is given by the formula 2n minus 1 into lambda by 2. The phase difference is given by the formula 2n minus 1 into your pi, where the value of n starts from your 1, 2, 3, 4, so on like this. Clear? Clear, beta? So delta phi is equals to 2 pi by lambda into delta x. Per maximum, what is the path difference? 2n n into lambda. What is the phase difference? 2n into pi. N value starts from 0, 1, 2, 3. Now for minimum intensity, path difference is 2n minus 1 lambda by 2, and phase difference is 2n minus 1 into pi. And n value starts from your 1, 2, 3, but not from your 0. Am I clear?
Yes, sir.
Let's see. For maxima, చెప్పండి ఆన్సర్ ఏమవుతుంది? ఫర్ maxima, if I am talking about, delta phi will be equal to n value 0 పెట్టుకున్నాను అనుకోండి, it will be 0 అవుతుంది. n value 1 పెట్టుకున్నాను అనుకోండి 2 pi అవుతుంది. n value 2 పెట్టుకున్నాను అనుకోండి 4 pi అవుతుంది. n value 3 పెట్టుకున్నాను అనుకోండి 6 pi అవుతుంది. Go on like this one. So for maxima, the phase difference is 0, 2 pi, 4 pi, 6 pi, go on. And maximum amplitude ఎంత అవుతుంది అన్న? A max is equals to under root of your, this one is a1 square plus a2 square plus 2a1 a2 into your cos of your phi. Okay, delta phi. Phi is 0 in అనుకోండి first one, isn't it? So it will be equal to how much for me? A max is equals to under root of your, this one is right now for me a1 square plus a2 square plus 2 times of your a1 into your a2. That means a max will be equal to a1 plus of your a2. A minima will be equal to how much, beta? A minima will be equal to your, I'll write later. A max maximum will be equal to how much for me? A max will be equal to your a1 plus of your a2, and phi value is equals to 0, 2 pi, 4 pi, 6 pi with anything. Okay. Now in the same way for minima, if I'm talking about, for minima, for your minimum amplitude is given by the formula a1 minus a2. Clear, beta? And amplitude intensity will be I minima is equals to root of I1 minus root of I2 whole square. I maxima ఎంత అవుతుంది అన్న? Maximum intensity I max is equals to root of I1 plus root of your I2 whole square. This will be the maximum intensity formula. Clear? So these are the formulas you need to remember for your maxima and as well as of your minima. For minima, for maxima delta phi value ఎంత అవుతుంది అన్న? 0. For minima delta phi ఎంత అవుతుంది right now? For minima delta phi value ఎక్కడి నుంచి స్టార్ట్ అవుతుంది అన్న? Take n value 1. 2 minus 1 is 5. So phi value will be equal to how much for me? Delta phi is equals to pi. దాని తర్వాత you take the value of your 2. 2 to the 4, 4 minus 1, 3. So this is 3 pi, then 5 pi, దాని తర్వాత 7 pi, like this. For these values, minimum amplitude, minimum intensity. క్లియర్ బేటా మరోసారి చూసుకోండి relation between path difference and phase difference is given by the formula delta phi is equal to 2 pi by lambda into delta x. For maxima we use the formula delta x is equal to n lambda and delta phi is equal to n lambda. n ఎక్కడ నుంచి స్టార్ట్ అవుతున్నా 0 1 2 3 నుంచి స్టార్ట్ చేయండి. For minimum delta x is equal to 2n minus 1 into lambda by. ఇప్పుడు కూడా చూడండి ఫర్ మాక్సిమం ఇంటెన్సిటీ డెల్టా ఫై వాల్యూ 0 అవ్వచ్చు 2 పై కావచ్చు 3 పై కావచ్చు 6 పై కావచ్చు. ఆ వాల్యూస్ కనుక నేను ఈ ఫార్ములాలో యూస్ చేశాను అనుకోండి వీఆర్ గెటింగ్ ద మాక్సిమం ఫార్ములాస్ ఆఫ్ యువర్ హౌ మచ్ వన్ ఏ మ్యాక్స్ ఇస్ ఈక్వల్స్ టు యువర్ a1 plus a2 అండ్ మాక్సిమం ఇంటెన్సిటీ విల్ బి ఈక్వల్ టు రూట్ ఆఫ్ i1 plus రూట్ ఆఫ్ i2 హోల్ స్క్వేర్. అదే ఫర్ ద మినిమం ఇంటెన్సిటీ మాట్లాడినప్పుడు ఫర్ మినిమం ఇంటెన్సిటీ డెల్టా ఫై పై కావచ్చు 3 పై కావచ్చు 5 పై కావచ్చు 7 పై కావచ్చు. అంటే a minima is equals to a1 minus a2 and I minima is equals to root of i1 minus root of i2 whole square. Am I clear? Sure. Question you'll get an idea. Write the question. Two beams of light, two beams of your light having intensities I and 4i interfere to produce a fringe pattern on a screen. Okay, the phase difference between beam is pi by 2 at point A and 2 pi at point B. Okay, then find out the difference between the resultant intensities at A and B. Okay, first option is 2i, second option is 5i, third option is I, and fourth option is 4i. So try to do it. Anyone? Two beams of light having intensity is how much better? I and 4i. Ante I1 is equals to I and I2 is equals to 4i. Okay. Interfere to produce a fringe pattern on a screen. The phase difference between them is pi by 2 when they are meeting somewhere at a point A. This is one wave and this is one wave. So phase difference between them is how much for me? Pi by 2. And when they are meeting somewhere at a point B, some other point of your B, the phase difference between them is 2 pi at a point B. And find out the phase difference between the resultant intensities of your A and as well as of your B. Clear? So let us try to talk about first intensity of your A. Intensity of A is equals to I1 plus I2 plus this is 2 root I1 root I2 into your cos of your 5. So I1 is how much better? I2 is how much for me? 4i plus this is 2 root of your I, this is root of your 4i into cos of your pi by 2. Pi by 2 means 90, cos 90 is equals is total 0. So intensity of your A will be equal to I plus 4i nano. Indukante cos 90 is 0. 0 multiplied with this all will become 0. So this will become how much for me? 5i. So intensity of A ఎంత వచ్చిందన్న? Intensity of A is equals to 5i వచ్చింది. Okay na? The same way for B if I am talking about. B got interfere అయినప్పుడు intensity of your B is equals to again I plus 4i plus this one is right now 2 root of your I root of your 4i into cos of your 2 pi. Cos 2 pi is how much beta? Anyone? 1. It will be equal to 5i plus 2 root I. This will be equal to root 4 is nothing but for me root 4 is nothing but 2 into your root of your I. This is nothing but equal to 1. Okay, so this will be equal to 5i plus of your, this is how much better? 2 into 2 4 root I into root I is nothing but I, so that will be equal to your 4i. So that will come out for me 9I. So intensity at your B is equals to how much for me? 9 times of your I. Okay. What is asking there? Find out the difference is asking. That means IB minus IA is how much? So it is 9I minus of 5I. That will be equal to 4I. This will be the answer. So what is the answer? 4I will be the answer. వచ్చింది అందరికి మరోసారి చూసుకున్నాను క్వశ్చన్ చదవండి జాగ్రత్త